Hello guys, welcome back to the channel. So in the previous class, we have discussed about conditional statements, if else, and also we have discussed about looping statements, for loop, while loop, and do while loop. And also we had a small talk about break and continuous statements. So in today's lecture, we will be discussing about functions. Functions. So let's start with the functions. So what is a function? Function or module is nothing but a set of program that performs a specific task which is required for the application. So a function is nothing but a block of code. Uh, so just let's read what is there in this definition here. Modules in C are called as functions. A function in C is defined to be the program segment that carries out some specific well-defined tasks. A function is a block of code that has a name and it has property that is reusable. So the main purpose of function is reusability. We can reuse it n number of times. That is, it can be executed as many different points as many different points in a C program as required. So there are two types of functions, right? So that is one is library function, another is user-defined functions. So library functions are like built-in functions which are predefined within the program itself, within the library itself. So all we need to do is just call the function, and we will be able to do those uh, function which we required for the for the addition or something. Okay, so let's read out what is the library function here. A C standard library provides a rich collection of functions that performing input-output operations, mathematical calculations, string manipulation operation, etc. So so these library functions are inbuilt functions performs what mathematical operations, mathematical calculations, string manipulation operations. Example, like we have an inbuilt function called sqrt, which is what it does is when given a number, it will find the square root of that number, right? So that is a purpose, that is the functionality of the sqrt. Or we also have some other functionalities like we can do square, we can do we also have floor function which calculates the lower bound of the given number, and we also have ceil function which calculates the upper bound of the given function. Or we can also have length function which calculates the length of the given string. Yes. So yeah. So to include all those functions, we need to use all these functions, we need to include the library functions in it. So for using all these library functions, we have to use math.h fighter file. So for using this printf scanf functions, so which have discussed in the earlier class, right? What is the scanf? What is the printf? These are nothing but input output functions. So these are also functions. So to use this function, what is the library which we need to use? So that there is nothing but hash include. H. If you include this library in your program, then you can easily able to use this printf and scanf. So without including this library function, you cannot use this function. This is very important to understand. Okay. Now moving on to this user-defined functions. User-defined function is nothing but a function which are defined by a programmer for the user purpose itself, for their own advantage, for their own what you can say in C, like let's see what is there here. In C language, the programmers write their own functions and use them in their programs. For the benefits itself, the programmers write the code. Okay. So now, how do you define? How do you define a user-defined function? So to define user-defined functions, we have to satisfy three properties. That is, we have to use function definition, we have to use function call, and we also need to use function declaration. So function definition is nothing but is an independent program module that is specifically written to implement the requirements of the function. This is nothing use of us for us. In order to use this function, we need to invoke it as required place in the program. This is known as function call. The program that calls the function is known as calling program or calling function. Uh, the calling program should declare any function that is needs to be later in the program. This is known as the function declaration or the function product. So what does this line tells us about? So let me erase this thing. Give me some space. Basically, what this 5 to 6 lines of paragraph saying is that let's say that we have a function A, okay, and now we have function B, okay. So in function B, we are calling function A, right? So this will what it will do. It will call function A, right? So this function B will be called as calling function, and this function A will be called as a call function. Yeah, right. So that's what it means. The program that calls the function is known as the calling function. So function B here is the calling function, and the calling program should declare any function that needs to be used at node here. Uh, Yeah, they were right? So to use all these function A, function B, first we need to declare those functions. So or we have to give function prototype for example, we have to right before the start of the main function, we have to declare all this function A and function B. Otherwise, if we won't be able to use. Otherwise, the compiler won't be able to understand what is function A and function B. So it is very important for us to give this function declaration. Okay. Now moving on to the next, how does the structure of a function? How does a function looks like? So we will explain it with a basic example. Okay. So there are two main parts of the function header and the function body. So given an example here, what does it say? Int sum, int x comma int y, int a n is equals to 0, a n is equals to x plus y, return s. What is it doing? It's finding the sum of x and y, right? Sum of x and y. So here a function will have two parts. One is header, another is body, right? So header, what does that header contain? Header contains the header contains three parts. One is name, another is parameters, third one is return type. So in the given example, this first line is called as the function header. So here sum is called as the function name, int is called as the return type, and x comma y are called are the parameters here. Okay, so that's what they have given here. Like name of the function is sum, parameters of the function enclosed in the parentheses. The parameters which are enclosed within these brackets are called as parameters. Okay, enclosed within the brackets are called as parameters, and the return type is int. Okay. Now, what is the function body? So after giving the function name, function header, whatever piece of code you write within this flower basis, it is called as function body, right? So now so what is a function prototype? Function prototype or function declaration are always declared at the beginning of the program. So indicating the name of the function, the data type of its argument, which is passed to the function, and the data of the return value from the function. So here it is called as function prototype. Like I have told you before, right? Here in the function declaration, we have to give it is mandatory for us to give function declaration because the compiler won't. If you don't give the function declaration, the compiler won't be able to understand what it means. What is this function? Where does it come from? Okay. Right. So the body is not required, just the function name. Function header is required, attached along with a semicolon, right? Here, if you read this line paragraph, we will be able to understand what this function prototype is. The prototype of a function provides the basic information about a function, which tells the compiler that the function is used correctly or not. It contains same information as the function header. Contains the prototype of the function is whatever would be look like. See, it is enclosed with it is attached along with a semicolon. It is similar to function header, right? Yeah. So now moving on to categories of function. So functions are categorized into four parts. One is uh, function with out arguments and no return value. Function so function with arguments and no return value. Function with arguments and a return value. Function with no arguments but a return value. So we are going to see all four examples of this category. Okay, one by one. Now let's see functions with no arguments and no return value. So how does it look like? Okay, it is very important for us to understand all these four categories because whenever function is declared, it must be categorized in any of these four functions only. No, there is nothing else. So let's understand what does this function with no arguments and no return value looks like. Okay. Hash equal stdio.h. What does it do? It will it is a library which will include all the standard IO input output libraries input output functions within this program. So that's what it do. And what is this? This is a function declaration. Now we are starting the function. Now we are writing the program void main. We're calling the add function. What does it add do? Add is not taking any arguments and not taking and also not giving any return value. So this is the example of no arguments and no return value here. See, we can also even understand, we can also get to know that whether it is which type of category it is, because in the calling function itself we can say that there is no return type, because if there is any return type, we should be able to catch it here. Like when if you equals to add, then definitely there should be a return value. Otherwise, there's no return type. And since we are not giving any parameters, it is there is no arguments, right? Yeah. So index comma y, and so we are simply adding two numbers. So this is an example of no function with no arguments and no return value. Now moving to functions with arguments and no return value. So now the function have parameters and will have no return value. So this will be empty, right? So it's the same thing in x comma y. We are calling, we are scanning, we are inputting two variables x comma y, and now we are calling the function add x comma y. So here, the difference between the above program and here is that we are having parameters here, x comma y, and there is no variable to catch the return value. So that means it is not returning anything. So we are simply returning the value of a plus b within the function add function itself. So this is what we call as a function with arguments and no return value. Now let's look into function with arguments and a return value. Okay. Uh, so the same thing here but here in the calling function, we are giving parameters, and also we are storing the return value in sum. So there is a return value, and also we can see here that there is a return type here, and then parameter also. So this is an example of function with arguments and return value. But I hope that you understand what this function is doing, right? It is nothing but is finding the sum of two variables. Sum of two variables, uh, two variables of user input. So all these three programs are doing the same thing. It is not doing any different. Only thing is we are changing the function call, right? I hope you are understanding this. Now let's look into function with no arguments but a return value. So here what we are doing, we are just simply returning the value and storing the value in the sum variable. Okay, and we are finding the we are within the add function, we are we are giving the user input x comma y, and then doing addition, and then returning that value and printing. So this is a prime example of function with no argument but return value. Okay, I hope it is very clear for all everyone. It's very simple to understand. Yes, now communication. So inter-function communication. So what does it say? Although the calling and call functions are two separate entities, right? Calling and call are two separate entities, right? They need to communicate to exchange data. The data flow between the calling and call functions can be divided into two strategies. One is a downward flow from calling to call function, and upward flow from the call to the calling function, a bidirectional flow from both the directions. So I hope I've explained what is a calling function or what is a call function, right? Let me explain it again. So for example, if there are two functions declared here, there is another function b, and this b function is calling a. Okay. So in the function b, since it is calling a, so b will be called as calling function, and a will be a will be called as call function. You have to remember this. Okay. I hope it is clear. I hope it is very clear to everyone. Now let's look into one inter-function communication of downward flow. So what does it say in downward flow? Here the calling function sends data to the function and no data flow in the opposite direction. So call function will not give any data to the calling function. So let's understand this example for better clarity. So here, look at here. In the main, int a equals 5, down function a. So here, this main is a calling function, right? This main is a calling function, and down function of a comma 15 is being called. Okay. So here, look at this. The down. function of int x comma y is being called and x equals x plus y return. Just a second. I think there is a typo here. It should be down fun. Okay. Yeah. So it is simply if you understand this code very clearly, the down function is sending the data. See the call, like I said, where is this? Here the calling function sends data to the call function. The calling function is sending the data of a comma 15 to this function, right? So, but in return, the down function is not sending any data because the return value is nothing. It is zero. So even if it is sending, it is not storing any variable, right? So this is a prime example of downward flow. I hope it is very clear. Simple. It is very simple that call function is not this down function is nothing but call function. Your call function is not giving back any data to the calling function. That's what downward flow means. Now moving to upward flow. So this occurs when the call function sends data back to the calling function without receiving any data from it. So look at here. If you look at the code of upward flow, here the calling function, here the call function. Here the call function is sending the parameters ampersand LA and ampersand LB, which means that it is sending the address of A and B, and then it is updating the values of AX and AY and returning them. Here this occurs when the call function sends data back to the call function without receiving any data from it. Okay, I hope this is very clear. So in bidirectional flow, the communication will occur in between the in bidirectional flow. The communication will happen in both the direction from downwards and upwards as well. Okay. Now let's look into type of function calls. So this is very important concept because this will be asked in many of this institute exams. This is very important for you to understand. So there are two types of function calls. One is call by value. Another is call by reference. Okay. So what is this call by value and what is this call by reference? So let's try to understand what are these two things. Okay. Uh, Call by value. Let's read it. What does it say? Okay. When a function is called by an argument or a parameter, the copy of the argument is passed to the function. If the argument is normal, non-pointer value, a possible change on the copy of the function in the argument in the function does not change the original value of the argument. However, given a pointer address value by any change to the value pointed by the pointer address changes the original argument. The following approach. So I hope so. We'll understand this call by value with an example. Okay. Uh, See, look at here. Int main. We are declaring few variables: float r comma a comma p, and scanning. We are giving the user input r. What we are going to do is we will be uh, finding the area and perimeter of r. Okay. We're using the function called area and perimeter. Here, see, we know the formula of pi r square. 2 pi r is the formula for finding the perimeter. So here, what does it say is that what is call by value says that if you are see when you are making a function call, you are sending the parameter r, right? We are sending the parameter r, area of r, perimeter of r, right? So whenever you are sending the variable r, okay, upon executing the function area, the value of r will not change. Even in the same case with the perimeter. If the value of r does not change, that means we are making a call by value. So call by value means we are just sending the value. Okay, we are just sending the value to the function, call function. This is very important to understand because it will be very confusing when I explain you reference. So call by value means that we are only sending the value. The value, what is the value of the value of user input? We are sending just that's it. We are not sending anything. Upon executing the area function area, and returning back to this area, this A, uh, and executing this function, main function, the value of R will not change at any point of time. This is very important for you to understand. Okay. Now we will move on to call by reference. Okay. So what do you mean by call by reference? Call by reference means that when area perimeter, right? Same thing. Let's say same thing. So when you are when you are sending area, we are not sending R, we are sending address of R, right? So Address of R means what? It is a reference. It is a reference to R. Uh, so address, we are sending address of R means we are sending a reference of R. So when this is being called and we are executing the area function, if you are changing this address of R, then the original value of R will also be changed. Will be changed. So there is a difference between call by value and call by reference. In value, the value of R will not change. In reference, if you send the address, then the address means you are sending a reference, then the value of R will be changed. There is a difference. Then nothing else. Let's try to read this call by reference and try to understand. When function is called by an argument or parameter, which is pointer, so pointer is nothing but the reference, the address, right? Address of the argument. The copy of the address of the argument is passed to the function. Therefore, so this address is passed to the function right here. Therefore, a possible change on the data of the reference address change the original value of the argument. So if you do any changes on this variable, which any if you do any changes on this reference variable, it will completely change the original value of R. So that's what it means by call by reference. So if you try to understand this code, so this example is nothing but we are sending the reference here, right? So just look at the, don't try to understand the code. We are just sending the reference ampersand L and ampersand LP. We are just sending the reference. Okay, that is enough to understand this example. Now let's move to this recursion. So recursion is also a very important concept in not just in terms of exams, writing exams, but also important in terms of coding. Recursion will reduce the code size. If you have a code of 100 lines, recursion will reduce the code to 10 lines or maybe 20 lines. So this is a very important concept for you to understand. So what is recursion? Recursion is a process of calling function itself. So a function will call itself. So if A, so here simple. A will call A again. A is being called again. A is being called again. So it's an infinite loop. So to remove this infinite loop, what we do? We add a if condition, right? So by adding a if condition, we will be able to terminate the if we will be able to, we will be able to remove the infinite loop. That is as simple as that. So let's try to give a demonstration of how the recursion works. Uh, what we are doing here, I hope you know what is the factorial of a number, right? If we fact of 5, what does it mean? It means that 5 into 4 into 3 into 2 into 1. So what, how much is 120? So fact of any number is n into n minus 1 into up to 1. That is the factorial of any number. Fact of n. Okay. Now, so what's going on here? So we are calling the factorial function a. We have to find the factorial of a. So if x equal to 0, return 1 is x into fact of x minus 1, right? Uh, so if let's do this, okay, with an example. Let's say we are giving so what will happen here? 5 into fact of 4. This is what will happen here. Fact of 5, 3. And what will happen here? 3 into fact of 2. What will happen here? 2 into fact of 1. What will happen here? Factor of 1 is what is the factor? 1 into factor of 0. So if the value of x is 0, what will happen? You have to return 1. So we will return 1 here. So 1 into 1, 2 into 1, 2 into 3 into 1, 4 into 3 into 2 into 1, again 5 into the 4 into 3 into 1. So what is happening here? We are calling the function itself. A function is calling itself. Right. And what is this terminating condition to eliminate this infinite loop? We're using x equal to 0. If x is equal to 0, we will return 1. So thereby we are eliminating the infinite loop. So I hope this is able, I hope you are clear with this recursion, right? Uh, so what are the features of recursion? There should be at least one if statement used to terminate the recursion because we will fall into infinite loop. Right. I've told you that before only. It does not contain any looping statements. So what is the point of using recursion if you're using loop statements, right? Simple like let me tell you how we can also do this factorial by for I equals to n, I less than I greater than or equals to 1, I minus minus, and fact equals to fact into I. If we do this, we'll be able to get the same factorial function, right? So what is the difference between this for loop and again factorial? So factorial recursion should not contain the for loop. That's what it meant. So two things to remember. We should not use for loops in recursion, And also there should be a terminating condition like if condition, right? Okay. Now moving on to advantages, it is easy to use. It represents compact programming structure, like it will reduce the lines of code. That's what this line mean. Tells us about. And yeah, disadvantage is lower than that of looping statement because each time function is called. Right? Calling a function takes a lot of time. It is time bounded computation. So yeah, I hope this is clear. And now let's see some standard functions like library functions. So C provides sets of collections of standard functions whose definitions have been written. So we have absolute function. What does the absolute function do? Uh, if there is an absolute value is a positive rendering of the value regardless of its sign. So if you give minus 3 ABS of minus 3, right? Wait, let me write it very clearly. So if you are giving ABS of minus 3, then it returns 3. So it will only return positive value. That's what it means. So ceiling function. So what does ceiling function do? Ceiling function will give you the upper bound of the variable. Like if you give 3.4 C log 3.4, it will give us 4. Okay. And also, see, look at this 3.00 minus it will give us 4. In the floor is quite opposite also, it will give you the lower bound of the function, lower bound of the number, and a truncate function returns the integral in the direction. So, I hope you just read this, just try to read all these functions. These are all inbuilt functions which are very useful for you to understand, and also it will be very helpful while you're doing coding. Okay. I think this is the end of the class. We have covered a lot of important topics today, and yeah, let's wind up the session today. Yeah, thank you.